Welcome to the Fire Protection Engineering Podcast, where we ignite conversation about fire protection engineering, safety, and innovation.
I'm Kelly Kidwell, and this is Ben Casey. We're both passionate fire protection engineers here to bring you the latest trends, in-depth insights, and expert advice from across the industry.
From designing fire safety systems to navigating code compliance to business development, we'll explore how engineering can help save lives and protect property.
Whether you're a seasoned pro or new to the world of fire protection, we'll dive into the critical roles engineers play in safeguarding the built environment.
So grab your helmet, check your smoke detectors, and join us as we spark some fascinating discussions about fire protection engineering.
Let's get started on today's episode of the Fire Protection Engineering Podcast.
And we're recording. Hello, everybody, and welcome to the next episode of the Fire Protection Engineering Podcast. I'm here today with Clarke O'Reilly. He's Sales and Marketing Manager for Pyrophobic Systems. Let me just read a brief summary of what Pyrophobic provides. A technology that is the core of Pyrophobic solutions, which provides fire-resistant polymer composites that contain proprietary and patented intumescent materials, which they combine with thermoplastic, creating powerful passive fire barriers and can be used as a base material in passive fire systems. It's a lot, and it's a lot of very specific chemical engineering and fire protection and material science that all went into that statement. So this should be interesting to talk through today. So Clarke, I guess take it from there and give us a little background of what Pyrophobic does and how you got there and where you're at with it.
Yeah, for sure. Thanks for having me, Ben. So a little bit about Pyrophobic. So our goal as a company, we are a fire safety materials company. Our goal is completely around fire safety materials. As Ben was saying, we play in patented intumescent thermoplastics, and basically we're trying to make the world safer for people, so that we're able to stop fires from spreading and mitigate them at the smallest source possible.
And so I guess maybe let's start with going into some basics of intumescents. I know a lot of our audience knows a lot about them, but are obviously used to a sort of a spread applied or painted on or spray applied intumescent coating as a fireproofing material. What are you all getting into that's different?
Yeah, so the basic mechanisms are going to be similar to an intumescent coating, where the goal is to expand as it heats, create a thermal barrier, and protect whatever we're trying to protect. Where we differentiate from those is we're using thermoplastics as our base carrier. So we're able to convert, we're able to injection mold, extrude, and actually make these into 3D parts that are certified and prepared off-site, so you're not sitting there waiting for paint to dry on-site.
And so the interesting thing, so I come across this looking into battery energy storage systems and I guess the latest innovations, the latest potential solutions for fire protection of those types of systems and products and places where lithium-ion batteries are being deployed, particularly in large commercial vehicle projects. And there's a lot of different ideas out there from active fire suppression perspective, whether it's a deluge system, whether it's, I've literally heard stories of cars broken down on the highway that are on fire and had to be lifted into a dump truck full of water in order to at least put out the fire in some method that involves something stopping it from burning and continue to burn without any other type of option. So trying to determine how to best prevent those types of fires where there's thermal runaway came upon your product, and just didn't realize that there was that type of innovation out there with Intumescents. So yeah, I guess explain kind of the largest use case, which I believe is the thermoplastics that are sort of in between the battery cells to prevent thermal runaway. Can you go into sort of how that works and what customers have been interested in?
Yeah, so in batteries, we play in a couple of different places with our intumescent materials. The cell spacers is one of the big ones. Reason being, we know that in order to stop a battery fire from spreading, we want to stop it at the smallest source possible so that it doesn't have time to thermally propagate up into a bigger event. So ideally, if we can get passive fire safety materials inside the battery, where they're sitting there inert, ready to react immediately without an active outside force, we're able to mitigate thermal runaway at the source instead of having to deal with it afterwards. So the way I like to think about it is for active systems, I guess EVs are difficult for active systems because it's difficult to have a sprinkler system or something like that. When we're looking at like an energy storage system or a building that has energy in it, I like to think of active and passive working together, where passive systems, their job is to compartmentalize things, is to break them down into smaller chunks that active systems can then suppress, is the way I like to see it. So our materials work well as that barrier, whether we started off in building construction doing poke through devices in fire rated walls. So any cement wall that's fire rated, if you cut a hole through it to pass electrical cables, data cables, anything like that, you've got to be able to reseal that hole. And then we were able to apply that technology trying to break down big fires and smaller fires to battery fires, where if we can contain it to a single cell or a single module, it's going to be a whole lot easier to use active suppression afterwards to control that down even further.
Yeah. And yeah, from a fire protection engineer's perspective, designing systems, I mean, I'm always looking for a passive solution before an active solution. I mean, because, essentially the building has to be built to certain construction standards and types of construction anyway. So if you can compartmentalize, then, you're not going to have to rely on systems that are dynamic and can fail, right? I mean, it's much better to rely on a passive system. And yeah, I mean, it's a good comparison, right? I mean, it's a through penetration fire stopping type concept, I guess. And in my understanding, so, the intumescent chemical is essentially incorporated into the thermoplastic and then molded to fit whatever scenario is required, down to the level of of putting it in as spacing between battery cells. Is that accurate? And I guess beyond that, that's the specific application I've been very interested in with your product and incorporating it into designs. I guess from there, maybe throw out some other ideas of like where that concept has been utilized by you all.
Oh, so that may...
Like, we talking about building systems? I mean, are you still like doing true penetration fire stopping for cabling? Where else are we talking?
Yeah, so other applications. So obviously we're playing in the areas that you were talking about as the cell spacers, cell holders, module spacers, that kind of thing. The nice part about that is being able to injection mold into an actual cell holder as opposed to using a potting mixture, using our thermoplastic. It can provide a little bit extra structure as well. And then other places that we play are places like bus bar terminal caps, where a lot of companies right now are using some generic like polypropylene materials, that kind of thing. But as they degrade in a fire, they're going to release conductive and flammable gases, which can lead to other arcing pathways that can lead to thermal runaway. So we're basically anywhere that fire can play, we can play. We're looking at a whole bunch of different applications in batteries, for cell spacers. Yeah.
And I guess let's just really quickly here, like I was saying earlier before we started recording, I don't want folks to think this is something you all just, put together in a garage in a bucket and came up with it and and know it works. You've got it UL listed, UL 9540A. Can you maybe just talk about some of the listing that you've gone through, and I mean, even talk about that process. I think folks are always interested in how long that can take and how much goes into it. So where are you at with that?
Yeah, so we've tested against as many standards as we can. So for energy storage, we're looking at the UL 9540As, the UL 9540. For EVs, a lot of OEMs right now are asking for UL 2596 for torch and grit testing to simulate both the torch and abrasion of the electrolyte coming out of a battery fire. For construction, we've tested UL 1479 and ASTM E814, which are kind of the standards for building construction fire safety. Yeah, so the origin of our actual intumescent material was originally for the Canadian Navy. They were trying to compartmentalize boats and be able to isolate individual rooms in boats to stop fire from spreading. So that's actually where our original idea came from in the 90s. And then it iterated from there to that it worked for construction. And then now we're looking at batteries as well, because anywhere that fire needs to stop, we try and stop it.
Interesting. And so you mentioned OEMs, original equipment manufacturers. A lot of folks think of OEMs as source companies for the larger product companies that we all know about. Like everybody knows about like Apple's OEMs and some of the things that have come out in the news with that. I think it's a little different for you, correctly. So maybe go through the process of working with OEMs from concept to production. Am I wrong? The OEMs are your customers to some, like it's not the other way around. They're not providing the plastics and you're providing the materials to them. Is that correct?
Yeah, exactly. So we see ourselves as what the automotive industry calls us as a tier 2 supplier. So we supply to suppliers that supply to the name brands. So we supply to the molders that then sell to the major automotive names that we all know, or to the people that sell to the end users, kind of thing. So we work with kind of in conjunction with both the end customer and any middlemen that they've brought in, fire protection engineers, that kind of thing, where we work through helping design, pick the right material for the job, where it needs to be applied best in the design phase. We truly believe that safety needs to be designed in inherently. I think you mentioned that earlier about buildings and passive protection, that it needs to be kind of the first and foremost. And as long as you're designing it in originally, then we can have great success kind of protecting things that we're trying to protect.
And you mentioned there briefly, obviously not to have to go through specific customer names. I'm sure there's some confidentiality there, but I mean, you're working with a lot of the major automotive manufacturers, right? You're a tier 2 for a few different ones, correct?
Mm-hmm.
Yeah, so it's already being used in a lot of like major vehicle technology that's coming out.
Yeah, and then we're also commercial in energy storage as well. Yeah, this is proven technology that's on the market. The main innovations that we're working on lately are kind of keeping up with the market to help with different aspects as the market's kind of changing. We're looking into kind of new mechanical properties to help with different aspects of stronger versus more flexible, that kind of thing. Yeah.
And the reason I keep sort of honing in on where your products use, the listings and the size of your company and the how long it's been around, it's interesting to me how many folks don't know that intumescents are used this way, correct? And like,
Mhm.
and it just seems like it's a no-brainer. I mean, it's a newer technological innovation than a lot of fire protection passive products, but
Mhm.
most folks don't know it exists. And even to the point of, like, we mentioned, earlier on in a few conversations, like I speak with a lot of different private equity and venture capital firms that are looking to acquire companies in the different fire protection or safety or resilience space. And the topic of fireproofing and passive fire protection manufacturers acquisitions has come up a lot lately. And I've brought up Pyrophobic, a few times, and they hadn't really understood or known that there was innovation in that space, right? And they're looking for sort of the use case between, intumescents and other types of fireproofing. I guess
Mhm.
it's interesting that there's that level of interest in acquisitions in a space that, maybe for a long time folks hadn't seen a lot of innovation in, and there may not be, a lot of differentiation as far as the margin is concerned. It's kind of a high volume product. It's sort of in everything to some extent. I'm talking about just generally fireproofing, right?
Mhm.
So maybe talk a little bit about why you think that is, and sort of what's going on out there. Why are a lot of these different companies looking to maybe acquire fireproofing or passive fire protection organizations?
Yeah, so I think there are a couple different reasons why companies would be looking to acquire fire protection companies, especially in the battery market right now. I think it's such a young market
Yeah.
that a lot of people don't know what's going on as far as fire protection for it goes yet. That it's still, everybody's learning. It's, call it 15, 20 years old as far as the actual real boom of the lithium ion market is gone. So I think that a lot of companies they started by trying to get a product onto the market, and then now need to figure out the fire protection side of it. That we've got something out there, but we know that it could be better, it could be safer, it could be a little bit safer for our customers. So
Well,
I think that
they
part of it.
literally may not be allowed to install the battery system
Mhm.
if they can't meet a fire marshal or an AHJ or whatever requirement. That actually that makes a lot of sense. So like, yeah, if you can combine those two things in an acquisition, perhaps you can, differentiate yourself and undercut your competitors. That's a good point. So,
Mhm.
and maybe there are already firms that are, have acquired lithium ion manufacturers, et cetera. But that's a good one. So
Mhm.
I guess, where do you see this, this topic in general, although, very technical, a lot of different moving parts as far as, like, as we talked about, chemical engineering, material science, fire protection, some new energy technologies involved sort of adjacent to this. I guess for safety professionals wanting to push the boundaries of fire safety, and that's, where Pyrophobic came in for me as a, performance-based option that does have the listings, is a tried and true product that others haven't incorporated in, and can save clients a lot of money in the back end instead of using some active systems. So, like, advice on sort of where you see other places maybe to push the boundaries, like how you all have gotten to this point.
Yeah, so I think the main benefit that I've found in the last little bit with fire safety engineers is when they really take safety as an inherent part of their design, and they start with safety as the paramount, that it's not going to be an add-on after the fact once you don't pass a certification because you hope that your first generation was going to be good enough. That the innovation is going to come in where where companies are looking to kind of push the envelope in higher performance materials that can do more for less space, less time, less energy, less money, and get better results for that. I think a lot of it's going to come down to the design phase from the engineers and making sure that we're starting from the right mindset and making sure that, yeah.
Yeah, I mean, yeah, when you're looking at things from a prescriptive perspective and you're thinking about code requirements, it's kind of a conservative way to look at it. And, my opinion is the people and society and, perhaps the government trend is becoming a little bit, sick of regulation. And there's a way, to make some of these solutions work with different innovative products, as long as they've been tested to standards and are, meet certain requirements, that can reduce the costs associated with over regulation, if you call it that, or look at it in a different way. So I think this is where, this comes in. Maybe the other thing to talk about, it's been confusing for me to kind of envision. Like, I've seen fire tests of intumescents that are spray or painted on to structures, and how they expand in a fire scenario to provide that passive fireproofing or fire resistance. How does your product work when it's injected or part of a plastic material? How does it provide the same kind of like dynamic activity during a fire? How does that work?
Yeah, so the real difference between our material and a spray coating or an application in the field or a paint of some sort is the base carrier resin. Is that we add our intumescent properties to our base thermoplastic resin. And once we mold that as similar to any thermoplastic, we're able to mold it into 3D dimensions, whatever shape we need. And as it's sitting there, it can clip on as a part over a bus bar, or it's sitting there as a cell holder, and it's just going to sit there until it's required to activate. Once it activates, it'll provide that protection.
And so the plastic polymer actually expands. Like, so I know you have videos on the website. I don't kind of want to like jump into something that we haven't really like looked at yet, but I can share a screen right now, or you can, if you think there's a video that may show this. I don't know if I hit it right now, over us.
Yeah, I don't have one loaded right now, but essentially, yeah, it's the same concept that it's going to expand and it's going to foam. Our material, the base polymer, essentially melts to give way for the intumescent properties to expand. Okay. And then as they expand, it creates a porous, non-friable char. It's releasing non-conductive, non-flammable gases that are going to supplant the oxygen that's in the area, so that we're not contributing to the fire triangle. And then that porous char is what creates the protection between the flame event and whatever we're trying to protect.
Okay, so the plastic polymer melts out of the way, essentially, like separates from the intumescent
to a certain extent, yeah. And then, but then being a thermoplastic, it also resets after the event. So the char is going to hold a little bit more structural rigidity than a thermoset would.
Okay, interesting. It's very interesting. Yeah, I know there's a few videos and different things on the website. Also, probably good time to mention right now, you also have a podcast. For those who want to look for it, they're on Spotify, the Fire Stop Feed Pyrophobic podcast. I'll also put a link to that on our LinkedIn page associated with this podcast and share it with folks. It's very interesting, goes into some of the material science, how they work with OEMs, etc. The OEM piece is always, I think, interesting to folks who are not that familiar with logistics and large manufacturing. especially in the architecture, engineering, construction industry. I mean, to us, it's just like, you know, the supply chain is taking forever, or for some reason, this product, you know, there's inflationary issues with this or something, you know, it's like, it's this like black box thing on the side that's just like annoying to construction managers, but we're never totally sure what's going on over there. So yeah, I mean, anything else you can kind of say about that manufacturing process? Like, what does it look like for you all? What are your facilities look like?
Yeah, so we essentially are a materials manufacturer. We make resin. That's our main bread and butter. That's our goal. We work with our customers in a couple of different ways, where either we can work with our own molders, injection molders, extruders, that kind of thing, or we also work with our customers if they have those capabilities on their end. But basically, we work through the design phase where we're understanding the concepts, we're understanding what we're trying to protect, what certifications we're looking to certify to, that kind of stuff. And we'll help iterate on designs to make sure we think it'll work. From there, we go into prototyping phases where we're making prototypes out of our material, doing the actual testing, some proof of concept testing first usually, and then into UL and ASTM testing for certifications. And then from there, we're into cutting steel to make molds for production parts. And once we're at production parts, it goes back to that first part of depending on how we set it up. But we can do all the way up to fully QAing and getting parts inspected. We have parts that are certified by UL that we sell into the construction industry already. So we can do it all the way up to the QA level as well.
Yeah, so that's the part that's tricky to me is, you know, going back to talking to private equity and venture capital, they don't understand that things are listed as assemblies, that the product is part of a overall listed assembly, right? That the fireproofing, the through penetration fire stopping is a piece of a whole. And so to that end, how much is the client or the customer of yours doing that sort of testing and certification with your product included versus forcing you to kind of make the part list? Like, how do you differentiate or figure out like what needs to be tested where?
Yeah, so most of our customers want to do a lot of the testing themselves so that they hold the final listing, and that's completely understandable. If they're putting their name on it to go to market with it, I understand them wanting to hold the final testing. And for companies like that, we support them with a lot of the baseline testing for the materials. So our materials are listed on IMDS and on different listing sites to make sure that we are compliant in different industries. So we can work with like that, or where we're doing all of the compliance.
Okay. And like what percentage of it would you say? I mean, are most of your products being tested in a larger assembly by the customer, or is it more on your end? Just curious.
So most are on the customer end, where they're implementing them into their systems, whether it's into their battery assembly or their building construction assembly. But a lot of the things, like in construction, we're a part inside of an assembly for poke-through devices. So basically, the plugins for any furniture in your cement floor or anything like that, we're a part inside of that. And we need to be certified as the actual material, saying that we made the material properly. And then the entire assembly also has to be certified, saying that it was assembled properly with our material in it properly. So it's hoops to jump through, but we get through them.
I was just thinking, I'm not sure I want your job. I mean,
Yeah.
my point is, it's the sales and marketing into such like you are essentially, there's so much being used and there's so much on the line, right? I mean, on the line, literally on the manufacturing line, right? So they're incorporating into this massive thing like a new vehicle, and then
Mhm.
thousands of them are made. So I can imagine the initial sales conversation is quite a process, right?
Yeah.
How long is that process from typically from start to finish? I mean, are we talking
Uh,
years to get into some of those products?
a typical sales cycle for us is probably like 12 to 18 months,
Okay.
realistically. Could be longer, could be shorter, but the thing is, once it's specified in, then we're kind of in, is the trade-off. So it takes a while, but if you do things properly and you design from safety first, then there's not going to be a ton of changes down the road, and we can kind of build a good relationship with our customers, and we expand a lot of times into different products that they're trying to put out as well. So it's the initial hurdle of getting people to understand what intumescent materials are, how to apply them, and all that fun stuff. But then once you get past that, most engineers are excited to work with it because they haven't dove into it. And once they do, I find a lot of engineers are very curious people and
Yeah.
like to get their hands on new stuff.
Yeah. The technical roadblocks are probably not as heavy as sort of the costs and the the supply side of the situation. But yeah, I mean, I as long if you can show that it's worked and you can show you have the bigger clients, I mean, it just starts to snowball from there, right? So I mean, for you personally, like, what motivated you to work in such a highly specialized field? Like, did you meet the original developers, or how'd you get into this?
Yeah, so I have a background in chemistry, like my
Okay.
degree's in chemistry. And then I've been in sales basically since university. I sold cars for a while, and then was kind of looking for something new during the pandemic, and found this that was kind of in the EV market, that was kind of in the science market, that was helping people save lives and fire
Yep.
safety, and yeah, it tickled the fancy.
There you go. The helping people save lives is what keeps us all pushing on this.
Exactly.
Um,
Yep.
and all right, so I guess really, where do you see the company going in the next few years? I mean, obviously, don't give away anything that someone could steal an idea from you, but I'm sure there's got to be some things flying around the office there where you guys are talking about the next innovation. Like, what does that what does that process look like? I mean, do you have discussions about sort of like a brainstorming session on what the next like entrepreneurial innovation will be, or is it just sort of a customer driven process? Like, where do you see this going? Where the company's mission going?
Yeah, so most of so we have a technical manager on staff, a PhD, that he's leading our R&D and developments and new developments. Most of our new developments right now, we're looking at staying in the intumescent fire safety realm, but looking at different formulations so that we can offer different mechanical properties versus different kind of cost and that kind of thing. Just developing a more well-rounded profile of fire safety materials that can be applied to more applications than we're currently being applied to. We know that there's a lot of room in the energy storage industry to kind of grow, as well as in the construction world, where there are different applications that intumescent, like you were saying, where intumescent paints and coatings and that kind of stuff are being applied. And if we can use a thermoplastic part and not have to have an inspection on site, inspect every single intumescent paint, that could save a lot of time and money.
Yeah, that's interesting too. Yeah, the inspection part of the passive fire protection piece is just a strange area. A lot of it is already covered over by the time the inspections start, and it's always an interesting kind of thing to try to work through a process of when you're building a building or working on it. I was just, as we're talking here, I was kind of scrolling through your frequently asked questions on your website. It's like probably the longest FAQ list I've ever seen in my life. But what seems to pop up a lot is the expansion ratio of the material, and that makes a lot of sense to me. You know, I'm sure there's engineers on the product side that are concerned that the expansion is going to, I guess, like break the material, the product in some way. I assume if it's already on fire, I'm not sure what the huge concern is there. But why does that question like seem like it's so prevalent?
So a couple of reasons. The first is when we're talking to engineers, their first concern about expansion is that it's going to displace something else and cause other issues from the pressure of the intumescent material expanding.
So cause like other issues. Okay.
Yeah. So that thankfully that doesn't happen with our material, is that it's not an outward force, that once it does fill the void of the space that it can fill, it'll actually create a more dense char and start to turn inward, which creates a better thermal barrier for us because it actually has more thermal pockets and more air pockets between the fire and what we're trying to protect. And then the other side is we've developed and changed our expansion ratios for different applications. So our building construction expansion ratio is from about 20 to 80 times of part size. So we have a part that goes inside of a light switch box, essentially, and it'll expand from that size up to about a sheet of paper that's an inch thick. So it's about 80 times its size. But for automotive applications, we don't have that luxury of having space to freely expand in a tight battery pack. So we've toned it down to about 2 or 3 times the part expansion.
Okay. So you've changed the material properties just to address those issues. And does that lower the fire resistance ability of the material when you're changing that type of expansion ratio?
So it changes it a little bit. It changes the duration that it'll last, as opposed to the temperature that it can survive. So what we were seeing with EV fires is that they're very instantaneous and they're very hot, where a building fire kind of has time to ramp up to get up to temperature. So we needed something in the electric vehicle market that's going to react now and react fast, where we needed something in the construction market that's going to last for 3 hours. It's just kind of different applications that need different solutions.
Okay. All right. Yeah. And I mean, what the interesting thing to me, and it's kind of maybe putting you on the spot a little bit, I don't want to get too much into numbers here, but I guess like what percentage of your sales in, I don't know, total quantity, revenue, whatever you kind of want to like think about it in general estimate, is going towards a type of building through penetration technology need versus like automotive versus where are you at right now? And then the add on to that question is like, which area do you think is growing more than other areas as a percentage of your total sales?
Yeah, so right now I'd say probably about 60 or 70% of our business is in building construction, between poke-through devices, the wall, the gaskets for the light switches, that kind of stuff, and then we also make the temperature rise mineral core for the inside of hollow metal door cores. So any steel door that's fire rated, we make the inside door, the core for that as well. It's not intumescent, but basically it'll allow enough heat to transfer through the door that when you touch it with the back of your hand, you can tell there's a fire on the other side, but that you don't get 3rd-degree burns on your hand. So between those two is probably about 70% of our business, and then the rest is in energy storage and EVs. I think the main areas for growth right now are in energy storage and in construction. The energy storage regulations are changing a lot, I think, in the next couple of years, and they're just going to keep getting stricter and stricter while people are trying to pack more energy into tighter spaces.
Yeah.
that their energy density is still leading the push for cost that you need to be energy dense enough to make it make sense. But that comes with inherent fire safety issues, that the more energy, the bigger the fire.
I didn't realize you were going to say such a high percentage for building needs. I guess you're probably talking about like clean rooms and industrial facilities where they really like cannot have any pass through between spaces. Is that
so clean rooms, building all the way up to hotels, retail buildings, anywhere that you can't have fire transfer from one area to another. So apartment buildings, any high rises.
so
Basically anywhere.
your product is actually a through penetration fire stopping for cabling systems, like for cable penetration. Okay. All right. I actually got it. Okay.
Yeah, that was
So
our original. And then
that
about
was your
10 or
original
12 years
stuff.
ago, then about 10 or 12 years ago, we switched to the energy storage and EVs and dove into that market. Yeah.
Got it. Okay. So I'm coming at it backwards.
Yeah. Historically, we've been a construction company.
Gotcha. Okay. And so I guess comparatively to other through penetration products, are others using intumescents in the basic building side of things? I mean, on the polymer side for lithium ion and that, that's innovative, extremely rare, I would say. I mean, I'm sure you have competitors, but we don't need to talk about them. But I'm just curious, like, where is that something that's typical in a lot of the through penetration systems now, or is it generally more of other types of materials in the market?
So for the through penetrations, it's a lot of intumescents. Other options on the market are a lot more thermoset though. So you're either two-part epoxies on site, or where you're casting into a hole on site compared to an assembly that's already been made ahead of time. So there are other solutions out there. A lot of them have similar properties by the time they're installed. It comes down to how you get to that final state of being able to stop it.
Okay. Yeah, the application being the difference. I'm just usually thinking of the applied ones versus ones that are part of a system, or a conduit system, or raceway system. It's interesting. So anything else? I guess we're coming down to the wire here. Any other sort of final thoughts or things that maybe we didn't touch on that you wanted to touch on?
No, I think we've talked about everything I was looking to chat about. That kind of my main takeaways for kind of the fire protection is looking at active versus passive and making sure you're using both appropriately, that they both have their place, and if used properly, that you can do some pretty cool stuff to stop some fires.
Yeah, I mean, even building owners, everyone would prefer to stick with passive. I mean, I love to tell the story where I went to Napa Valley, and there is a Castillo de Amorosa, which I probably just pronounced completely wrong, but essentially a gentleman built a scale European castle as a winery and vineyard in Napa Valley. And I met him while I was there, and I told him what I did, and he just went off on a giant rant about how the fire marshal made him put a sprinkler system in a castle. and to some extent, obviously it's what's in the place that burns, sir. It's not the building, that sort of standard response, right? But it speaks to a point where, really everyone wants a passive solution. No one wants an active solution. And, I know there's folks listening that are from fire suppression and fire alarm manufacturers, and there's always going to be a need for that. But from an owner perspective, they're looking for a passive solution. And so trying to implement as much as we can, it's never going to eliminate an active system, but having it as part of an overall holistic fire protection solution is very important. And I think that, owners and others who don't know that much about it that's what they want. So, even from that angle, it's very important to consider these kind of products. So yeah, no, it's interesting to talk about. This was, as I started out with that, that blurb and summary of your product in the beginning. It's kind of a tough, specific topic, but I think we covered what most folks would be curious about. And no, I appreciate your time. And yeah, let's keep working together and get these systems into different products.
Awesome. I appreciate it, Ben.
And as I've said a few times before, Kelly said she had to miss this one as well, but she will be back in future episodes. And we'll talk again soon, Clarke. Good to talk to you today.
Yeah, you too, Ben. We'll talk to you soon. Bye.
And that's a wrap on today's episode of the Fire Protection Engineering Podcast.
We hope you found today's discussion as illuminating as a well-designed sprinkler system. That makes no sense. Remember, fire protection engineering is all about making spaces safer for everyone.
If you enjoyed today's episode, be sure to subscribe, rate, and leave a review. And don't forget to share the podcast with anyone you think could benefit from it.
Got questions or topics you'd like us to cover? Drop us a line on social media or through our website. We love hearing from our listeners.
Thanks for tuning in, and remember, safety is no accident. Until next time, stay safe and keep engineering for a safer world.
See you next time on the Fire Protection Engineering Podcast.